Hi, thank you all for being here. I am very excited because today, together, we will revolutionize the entire movie streaming industry as well as society at large. Before we get started with that, it's quite a big task. Before we get started, just as a note, we will have some videos later on in the talk where there are some like flashing images. It's nothing super severe, but if that's something you don't want to see, you have plenty of time now to like leave the room. Okay, that said, our scenario for today is one that all of us have faced before. Namely, we are bored and we would like to stream some movies. Specifically, we want to watch these 3 movies, which I have very arbitrarily selected. We want to watch Everything Everywhere all at once. We want to watch as well as Knives Out. And if we want to do that the usual conventional legal way, then we would have to go to whatever WoW is for Everything Everywhere. We would have to go to Disney Plus for The Favorite, and we would have to go to Netflix for Knives Out. Now, if we go to the websites for all of these streaming services and we arbitrarily select a price for their 12-month plans, we can kind of start to calculate how much that would cost us. And it's a lot of money. If we add that all up, we would have to pay to get access to these 3 movies whenever we want, over a year, 919 euros. I don't have that kind of money. So what we are going to build today is something that can do exactly that can stream all these movies and can do it for free and without violating copyright, hopefully. Now, even if we spend these 919 euros, if you are anything like me, your Wi-Fi at home is complete garbage. And so even if I start up Netflix, odds are that I'm going to see something like this. Trash quality, very pixelated, barely watchable. So what we also want to do while we're at it is we want to completely revolutionize video compression. And we want to get these movies down from these unwieldy file sizes of like 20 gigabytes or whatever it is to something much more manageable. And then finally, once you are on Netflix and you have selected the movie you want to watch and your Wi-Fi is cooperating, you still might notice that there are some systemic problems plaguing Hollywood and that the people that we see represented on screen seem a bit biased towards white men in general. So maybe we could fix this as well. With that, I invite you to join me in the revolution and fix all of these problems in the span of a 30-minute talk. Before we get to actually building a cool new streaming service, though, we'll have to do a quick detour where I will get into where all this is coming from. And a couple of months ago, we had a guest lecture here at TU Darmstadt from a professor from Berkeley, David Baman, who gave a talk on a recent paper of his, which is called Measuring Diversity in Hollywood Through the Large-Scale Computational Analysis of Film. That's a kind of interesting topic, and it was a great talk. And it kind of stuck in my brain for a long time afterwards. And essentially what David and his team did for this paper was they bought 2,307 DVDs off of Amazon for the top 50 box office grossing movies in the US from the 1980s to 2022, as well as like award nominees. And they got some sort of special copyright exemption clearance. They talked to a lot of lawyers and were then permitted to circumvent the copyright, like the copy protection mechanism of the DVD, and legally analyze these movies in like a cloud server setup that had to be highly secure, and no one was under any circumstances allowed to enjoy the movies while they were doing the research. But they did all of this work, and now they have these digitized movies, this large corpus of movies. And then they did some interesting analysis on that, which looks a little like that. because essentially they ran a facial recognition pipeline over the entire movie, or over all of these 2,000 movies. And what they ended up with is, for every frame in every movie, they have the locations of the faces in that frame, as well as the actors that face belongs to. And once you have this data, you can do very interesting and cool stuff and kind of track the representation of gender, of ethnicity, of all sorts of things over almost 50 years of film history. And I brought some of the graphs from the paper. None of this is my own work, but I think it's cool, so I wanted to show it to you. We can, for example, look at how women are represented on screen in these Hollywood movies ever since the 1980s. And we can see that in terms of screen time, face time percentage, we are still in a bad place. We are still hovering at about 25, maybe 30% of screen time that women are getting compared to men. But on a positive note, we can see a slight upward trend there in the last couple of years towards more representation. And there's a similar pattern when we look at ethnicity, where we have an even stronger bias towards white actors compared to other ethnicities. But now, at this point in the presentation that I listened to, David was describing like how you get all this data, and I think I was really impressed by the research because it's very thought through. Because there's other works where they would basically, if we skip back here, at this point where you have detected the faces, they would use a machine learning classifier and throw that on there and say, okay, is this a man or a woman? Which is problematic, it's inherently binary, it doesn't really work. And so he addressed that and he said, okay, we will actually match that to the IMDb IDs of the actors, then we can match those to Wikidata entries, and from Wikidata we can actually get like a canonical gender for the actor that is being portrayed there. And at that point, I was like, oh my God, I have such an annoying question. I'm gonna really trip him up, right? Because I bet that Elliot Page really fucks with your data set. But before I even finished that thought, and without any interaction, he went on to say, of course, we have to account for Elliot Page in this data set. So what they are doing is not only are they getting gender data from Wikidata, they are getting time-stamped gender data. So for every actor, they check kind of the public perception of that person's gender at the time the movie was released. And that was kind of the point where I was like, okay, yeah, you know how to do good research. I'm impressed. That's kind of cool. Okay. But moving on, we can also do a bit more complex analysis. So you can also look at leading roles versus non-leading roles. And what you see there is also not super surprising, but we now have very cool data to show that white men are incredibly overrepresented in leading roles compared to non-leading kind of extra background roles. And that is in contrast to basically every other dimension of gender or ethnicity, which is more represented in non-lead roles compared to leading roles. So this is the research. This is cool stuff, important, interesting. But what kind of stuck in my head more was this image. And I started thinking about, okay, they went through this entire process to get copyright clearance and to be able to buy these movies, to extract this data, to run this pipeline. And the movies are, of course, still copyrighted. But the data that came with this research paper, that's licensed under a Creative Commons license. So these rectangles that you see in the image, those are publicly available. We know for all of these thousands of movies, where are the actors at which point in time? And so naturally, you could start thinking, what if we reconstruct the original movie from this data? And then we would have like a copyright-free clone of the movie based on only Creative Commons data. And if we do a really quick mock-up of that, that could look something like this. You see rectangles and IMDb IDs moving over the screen over time, but that's not really fun to look at. So this is the raw data behind that. It's scattered across different files, and I think you can make some comment there about like researchers and messy data sets and stuff, but I'm not gonna. What we have here is IDs, sequential IDs for tracks of faces, which is like one instance of a face in a movie moving across the screen. And for each of these tracks, we have the face recognition results, which give us essentially a confidence score for this track of how likely it is that a given actor with their IMDb ID matches this face. And then in another file, we have bounding box coordinates in pixels for every frame that a given face track appears in. And then in a third file, we also have scene transitions. So every time the movie cuts to another camera angle, that is also detected, and we have the frame boundaries for these scenes. And now if we want to make all this look nice and visualize it in a cool way, we have to put some images, some real people behind these moving boxes on the screen. And so to do that, we just go on IMDb, we click through the images for the movie, we see an image we like, and we use Android's built-in background removal to get a transparent PNG for that actor. And then we can take that PNG and we run it through a pretty tiny Python script. And Python continues to amaze me because it turns out you can just write import face recognition into a Python script and it will kind of work. So what we do there is we have our transparent actor PNGs, and we let Python recognize faces in them, and then we also have these bounding box coordinates for the faces in our actor images. So now we have an actor image with a face rectangle, and we have also a movie with face rectangles. And all that we have to do now is kind of lay the two on top of each other. Except it turns out there's a lot more people in movies beyond like the top 4 listed actors. And if you want to try this yourself, I found it quite interesting that if you go to like the 5th or 6th ranked actor in an IMDb entry, chances are you're not going to find a good picture of that person because like the fame drop-off is apparently quite steep. So for all the people that we can't match to a nice face of an actor, we just go to Unsplash and we type in person and we just pick some random images of people and we do the same thing. And so everyone who we don't recognize will just be represented by any of those people. If we glue all of this together, we get kind of a first draft of what we are trying to do. And that looks like this. And you can notice that that doesn't look good yet. It's kind of flickery. You see the people disappearing, reappearing, changing shape. So it turns out we have to do some more pre-processing of the data beyond what David and his team in the original research did, because obviously that was not what they were trying to do. We have to kind of adapt the data. And so what we do is we look at the face rectangles, and if one of them disappears and then we have silence for a couple frames and then another rectangle reappears in a very similar position, well, we can assume that the person in the scene just did something like this. And now the face recognition algorithm can't detect me anymore, and then I turn back around and now the rectangle is back. So what we do is we just add additional rectangles interpolated in between these two positions if a face disappears for only a couple frames. And then we also do some tricks to say if an unrecognized face disappears and another unrecognized face reappears somewhere close, that is probably the same person. So we then pick the sprites that we display carefully so that those will get the same image representation, even though it's not an actor that we recognize. And with that, we have now successfully freed movies from copyright forever or something. And I just want to take like 30 seconds to show you what the movie that this talk is titled on, Everything Everywhere All at Once, looks like in our Few Things Everywhere All at Once version. I have a couple highlights that I stitched together for you. And I think it's kind of cool that you can still get a vibe of the movie. You can still kind of tell which conversation is going on. You can still tell if it's like an intense scene, if there's like weird special effects and quick cuts. And we have our gorgeous extras in the background, of course, when there's random faces. So this is really promising, and we have already achieved one of the things that we set out to do. Now we only have 2 more remaining. The second one, if you remember, was about file size. So we want to really crush this movie down to something that we can stream over mobile data or whatever. And because I am a scientist and we are doing this in a very scientific way, we need reference material, right? We need a baseline to compare this against. And this is difficult because this is a copyrighted movie, and so it's very difficult to find files where we can see how much data an encoding of that movie would take, right? There's really no efficient way to do that. Now we can look at these torrents that we've seen before that have like 22 gigabytes, very large files. That's going to be really easy to beat. So I also want to have a baseline that really shows us how far we can push the state of the art in terms of file size, so have a fair fight. And to do that, we turn to FFmpeg, everyone's favorite video encoding tool. And that actually has a 2-pass mode where we can set a target file size to compress our movie into. In the documentation, it gives you this example bitrate, like 2,600 kilobits per second. And, well, we can just try how far we can crank that down, right? And we can just tell FFmpeg, OK, usually you do 2,600. Can you do it with, like, 10? Can you do 10 kilobits per second? And surprisingly, FFmpeg will actually let you do this without even complaining. And it will give you this file, which is 11 megabytes large. And it is a complete encoding of the 2-hour movie, The Favorite. And if we look into that, this is what the state-of-the-art compression looks like. And I think we can all agree that the Few Things approach blows this out of the water in terms of quality and in terms of file size. Because if we look at file sizes, this is a log scale, by the way, because we are doing science and we are comparing very different orders of magnitude. We have 2 randomly picked torrents from the Pirate Bay. Then we have the theoretical capacity of a normal DVD, around like 4 gigabytes. Then we have a best effort calculation of how much bandwidth Netflix would use to stream this movie in regular HD resolution. Then we have our FFmpeg encoding, which takes about 11 megabytes. And then Few Things actually comes in at only like 5 megabytes. So really, really, really tiny. And as you've seen previously, basically visually lossless, right? And it becomes even more impressive if you factor in resolution. Because of these baseline files, the first torrent was the only one to go above full HD. That's like a 2160p encoding. The DVD is 720p. Netflix and the other torrent were 1080. Our FFmpeg encoding is also 720. But with Few Things, we now basically have something like a scalable vector video format. So as long as the pictures of the actors that we put in are large enough, we can scale the resolution to whatever we want. And that's why I'm calling this a K plus resolution. So incredibly high res, incredibly tiny, truly revolutionary file compression. I'm going to file a patent or something, I guess. But with that, we can move on to the last challenge, which is kind of the most complex one, right? Because this is like a social issue. It's very complicated. It's rooted in history. There's lots of complexity. And usually what helps in these situations is if we just try to fix them with a simple technical solution. And that's exactly what we're going to do. Because we've seen that certain types of people are underrepresented in Hollywood and on screen. But now, earlier, we were just pulling random people's faces off of Unsplash. And so if we, for example, want to see more queer and trans people represented on screen, we can just swap out a couple images. And then we can watch this version of The Favorite, which sports all of our favorite trans actors in the background. And I mean, to me, that's the version of the movie I always wanted to watch, right? Of course, this is super flexible and could also be adjusted to whatever a certain user's preferences are. For example, if you are really into Emma Stone and you watch The Favorite, one of the core shortcomings of that movie is that there's only one Emma Stone in there. With Few things, we can now watch this version of The Favorite, where every background actor is another instance of Emma Stone. Okay, so there's already quite some potential, but that was just surface level stuff, right? We just swapped out background and extras. And we've already seen previously in the analysis that we won't get away with that if we want to fool David Baman and his team, because they differentiate between lead and non-lead actors. So we pushed non-lead representation, that's cool, but we can do more interesting things. And now I thought it would be fun to show that we can make the relationships that are displayed on screen more queer by swapping out people. Then I looked at the selection of movies and I was like, none of these actually feature a prominent straight relationship. So what we are going to do instead is we are going to make movies more straight, which is basically the same thing in reverse, right? So we're going to take The Favorite. And if you haven't seen that movie, a central figure in the movie is the Queen of England, who you see in the middle here. And she's kind of a hopeless lesbian, and two of her maids, her attendants, are kind of vying for her attention, trying to play her to their advantage, to gain the upper hand. And so if we want to make this a more straight movie, all we have to do is we have to find some other monarch that we can cast instead. And a quick Google search for King Charles gives us exactly what we need. And so now we can watch this version. This, by the way, are kissing scenes where they are like putting fingers in each other's mouths very seductively. Just so you have that context information, I thought that was important. Yeah, and with that, we have achieved all of the things that we set out to do. We have freed movies from copyright, we have absolutely revolutionized file compression, and also fixed all of society's issues. And the thing that we built is actually live right now. You can watch all of these 3 movies in their entirety on my website if you like. The link is on this slide again. There's also my Mastodon profile. Feel free to give that a look. And thank you so much for being here and for listening.